Hello everyone, welcome to the October 2023 edition of Skyviews. I'm Dr. Jacob Hamer, Assistant Curator of Planetarium Education at the New Jersey State Museum. Since it's October, I want to tell you about an especially spooky star easily visible in the sky this month. But first, I want to make sure you're ready for this month's partial solar eclipse. On October 14th, an annular solar eclipse will occur in parts of the western United States. Solar eclipses happen when the moon passes in between the Earth and the Sun, and the moon casts a shadow on the Earth. But solar eclipses don't happen every time there's a new moon, because the moon's orbit around the Earth is tilted. The tilt is about 5 degrees compared to Earth's orbit around the Sun. So during most new moons, the moon doesn't pass directly in front of the Sun from our perspective, but roughly every 6 months, the configuration of the moon's orbit is just right for the moon to pass right in front of the Sun. So what's an annular solar eclipse? Annular solar eclipses occur when the moon happens to be at the most distant part of its orbit at the time it passes between the Earth and the Sun. Being slightly further away means that the moon is slightly smaller in the sky, too small to block the entire disk of the Sun. The small ring, or annulus, of Sun that remains visible during an annular eclipse is still extremely bright, and so it's a very different experience from a total solar eclipse. In a total solar eclipse, the entire face of the Sun is covered by the moon, and the tenuous, extremely hot outer atmosphere, the corona, becomes visible. However, here in New Jersey, we're not in the path of the annular eclipse. We'll just have a partial solar eclipse, where about a quarter of the Sun's surface is obscured by the moon. But to view any eclipse, you'll need special equipment to make it safe: eclipse glasses. These glasses block thousands of times more light than sunglasses, which makes it safe to look at the Sun, and you can buy eclipse glasses online. Another option for viewing the eclipse is to make a pinhole sun projector. One way you could do this is to take an index card, punch a small circular hole in it, and then let the card cast a shadow. The Sun will project an image of itself through the small hole, and you'll see it in the shadow of the card. You can find instructions to make one of these projectors online. You can even make a small hole with your fingers to replicate this, like in these pictures I took during the 2017 total solar eclipse. Here in Trenton on October 14th, the partial eclipse will begin at 12:06 p.m. The maximum obscuration of the Sun will occur at 1:22 p.m., and the eclipse will end at 2:37 p.m. We'll be observing it here at the museum, so come join us. Now, since it's spooky season, let's talk about a spooky star called Algol, also known as the Demon Star. Algol is in the constellation of Perseus, the Greek mythological hero who slew Medusa. On Halloween, Perseus is just above the northeastern horizon after sunset, sitting below the W of Cassiopeia. By 9 p.m., it's 40 degrees above the horizon. In many artistic depictions of the constellation, Perseus is shown holding the head of Medusa, with Algol often depicted as Medusa's eye. Algol's name comes from the Arabic Ras Al Ghul, meaning head of the ogre. So what's so spooky about Algol, and why does it have such ominous names? About every 3 days, Algol gets 3 times fainter for about 10 hours. How could this be? The answer is related to what the first half of this video is about: eclipses. Algol is actually a system of 3 stars. 2 of those stars orbit each other in such a way that one passes in front of the other, and vice versa. One of the stars is much hotter and brighter, and when the faint one passes in front of it and blocks its light, we receive much less light from the system, and we see Algol dim. Systems like this one are called eclipsing binary stars, and they're valuable tools to help astronomers better understand stars. So does Algol have such spooky names because of its spooky behavior? The first time Algol's brightness variations were explicitly described as being periodic was in the 17th century by the 19-year-old deaf astronomer John Goodricke, long after it was named. However, it's still possible that it gained its name because of its strange behavior. We may never be certain of the connection between Algol's variability and its name, but in my opinion, it's likely. Humans have been carefully and perceptively watching the skies for millennia, and I doubt that they missed a star winking back at them.